All right, today's lesson is on 8.4, simplifying rational expressions. So we're starting this new unit for chapter 8. We'll do a few sections in here. We'll kind of skip around the order. So the number might not be that important to you, but it is out of our book. So let's talk about what a rational expression is, because that's what we'll be looking at this entire unit. It is a quotient of two polynomials. So quotient is going to mean a fraction. So this entire unit will involve fractions. You're welcome. All right, so we will put we're going to be simplifying today, so we're going to put it in simplest form. And it'll be in simplest form when the numerator and denominator have no common factors. Okay, so things like 2/4, right? That's not in simplest form as that fraction because they have a common factor of 2. I could divide each of them by 2. Now 1 and 2 have no common factors other than 1, which wouldn't count. All right, so we're going to be simplifying our fractions, but polynomials are going to have variables, exponents, things like that. So it'll be more complicated, obviously, than just 2/4, but that's what we'll be looking at. So when things get more complicated with these complex polynomials, to figure out how to simplify or what common factors they have, the big thing that we will be looking at today is that we must factor the numerator and denominator. To find those common factors. Okay, and just like up here, we would divide out those 2's and get rid of them and get down to 1/2. That's what we will do as well. All right, so we'll look at an example here. I want you to simplify x squared plus 7x plus 10 divided by x squared minus 3x minus 10. Okay, so this would be a rational expression. I've got a polynomial in the numerator and a polynomial in the denominator. All right, so some students might start slashing things out and they notice there's an x squared on top and an x squared on the bottom, and they think they can cross those out and divide those. You cannot do that. If I had 2x squared over 3x squared, sure, I can cross those out and divide those. Okay, some of you might not see any difference between what I have up top and what I have here for my example. The difference is those are multiplying. All right, I am adding 7x plus 10 to this x squared. That makes this problem more difficult, and I cannot divide those out because they're not factors unless it's written in a multiplied form like up top. Okay, so what I must do is I must factor my numerator and factor my denominator. Okay, so we are in the chapter now where we are going to do a lot of factoring. Okay, I promised you that that would come back again after chapter 4. Here we are. Okay, so what multiplies to 10 but would add to 7 would be 5 and 2. They're both positive since I have plus and plus. So then I will factor my denominator. So I've got x times x to get my x squared. What multiplies to -10 but adds to -3 this time would be a -5 and a +2. All right, so the reason why we want to factor it is we're trying to find those common factors and divide them out. All right, just like my 2/4, I could write that as 2 times 1 over 2 times 2. We wouldn't do that because we can do that in our head pretty easily, just divide 2 out of the top and bottom. But we could write it as that, then cross those out because 2 divided by 2 is 1, so you're left with 1/2. Okay, we could do that, but typically we can just do that in our head. So here what I'm looking at is I have 2 common factors. I have an x plus 2 and another x plus 2. So that would represent the same exact number. Right? If I had a number for x and I add 2 to that number and I add 2 to that same number, it would be the same number. So I can cross those out and divide them. That would give me 1, and I wouldn't have to include 1 in my answer. So now I have x plus 5 divided by x minus 5. All right, that is my final answer. There are no more common factors because all I have written now is addition and subtraction. It has to be written in a multiplied form to see that factor. So those common factors would be 1. So we are done. Something else that you'll be asked to do will be to find the restrictions on your variable. So your restrictions are going to come from what x could never equal. Because we have all these variables in our denominator, remember you cannot divide by 0. So that's what you're finding in your restrictions. Okay, so we could not have 5 be the answer for x because 5 minus 5 would be 0 and we can't divide by that number. So we could never have 5. Okay, when we're writing these restrictions, we're writing the restrictions for a simplified form, but also for the original problem. Okay, because our simplified form is nice. So if I plug in a value of x in my simplified form, I'm going to get the same exact answer as if I plug in a value of x in my original problem. Okay, but if I plug in one of the restrictions, I would not get an answer for the original problem, but I might get an answer for the simplified part. So we got to make sure that we check all of our factors in our denominator, so including the one that we crossed out. All right, so it also cannot equal -2 because -2 plus 2 would make that denominator also 0. So I look at every separate factor value that would make my denominator 0 and only the denominator. Okay. All right, so that is how we will simplify. Basically factor, cross out the common factors in the top and bottom, find those restrictions by looking at every factor in your denominator. Okay, so you'll have a few that are just simplifying like that. I want to look at, today we're also going to do multiplication and division with these and then simplifying. So we are going to look at a problem where we multiply the rational expressions. All right, so this example would be 2x minus 8 over x squared minus 16. That's one rational expression, and we are going to multiply it by x squared plus 5x plus 4 divided by x squared plus 8x plus 16. Okay, what you do not want to do, if you think back to how you multiply fractions, so just something simple, we multiply straight across the top, straight across the bottom, that would be my answer. Technically, yes, you can multiply straight across the top and straight across the bottom. You are going to get you're going to have to distribute 2x times x squared, 2x times 5x, 2x times 4, and then -8 times x squared. So you're going to get a huge polynomial, and then you will have to factor it after that. And some of you might not be able to factor something that gets that complicated. So I would not suggest multiplying straight across the top and bottom at this time. I would suggest factoring every numerator and denominator that you can and rewriting it that way, because I'm trying to find those common factors in the top and in the bottom. So really this can be just one giant fraction, because yes, you are multiplying across the top and bottom, but let's separate all those into separate factors and figure out what's in common in the top and bottom. So if I'm factoring 2x minus 8, make sure you factor out those greatest common factors. Some of you were forgetting to do that and getting things wrong in Math Excel or on our Chapter 4 test. If you forget to do that here, you're not going to be able to simplify correctly. So that will become an issue for you. Let's go ahead and factor x squared minus 16. That's one of those difference of two perfect squares. So x plus 4 and x minus 4. I'm just going to leave this as one fraction. I'm going to factor my x squared plus 5x plus 4, so x and x. What multiplies to 4 but adds to 5 would be 4 and 1. I'm going to factor my x squared plus 8x plus 16. So I'll need my x times x to get x squared. What multiplies to 16 but combines to 8? That would be 4 and 4. All right, now I have factored everything. So take a look at what we got. We need to see what common factors are in the top and in the bottom. So I have an x minus 4 would divide out with my other x minus 4. I have an x plus 4 that would divide out with another x plus 4. So now I have students that will ask, well, can this x plus 4 divide out with those? No. It is only one x plus 4 can divide with one of the x plus 4s. I would need more of them on top to divide out with the bottom. So I'm going to have more stuff left in the bottom than I do on the top. That's fine. Okay, so I found all the common factors. I need to write what's remaining. There's still a 2 here. There's still an x plus 1 here. So that's all that's remaining in my numerator. In the bottom, I would still have this x plus 4 and this x plus 4. So you can write it twice or you can write it squared. Okay, to save you some time and kind of typing all that out too in Math Excel. And that would be my final answer. There are no common factors remaining. You do not need to distribute this. So some students will want to write, oh, 2x plus 2 over, if I square that, that would be x squared plus 8x plus 16. All right, some students will want to write their answers like that because they get so used to multiplying things out. You do not have to do that. And honestly, I don't know if Math Excel is going to accept that answer. This is considered the simplified form. We want that factored form because now right when I look at it, I know for sure that there's no other factors. When I look at this off the top of my head, I might have to write that in the factored form just to make sure there wouldn't be any common factors. So your factored form, this factored form is the best way to write your answer. Okay, and then don't forget your restrictions on your variable for x. So the things that we cannot have x equal, I need to look at every different possibility of the factors in my denominator. So what value of x would make x plus 4 equal 0? Well, then we can't have negative 4 because negative 4 plus 4 would be 0. Okay, if I look at this one, x minus 4, that can't be 0. What's going to make that 0? A positive 4. Okay, this would be negative 4 again and another negative 4. So those are my two restrictions that I can't have because those are the only different numbers that would make my denominator factors 0. Okay, so we simplified, we've multiplied, now we are going to divide. Quick refresher to divide a fraction. Right, if I take 3/4 divided by 1/2, okay, yeah, you can type that in your calculator and it'll spit out an answer for you. When we throw in our variables, you can't do that. So let's look back at an easy problem that you learned in elementary school, I think 5th grade. All right, so I've got 3/4, then I change it to multiplying by the reciprocal of that second fraction. So I would flip that over. Okay, then from there, you're typically taught multiply straight across the top and bottom. If we think about what we're trying to do, right now we're trying to find those common factors. So you could write it as 3 times 2 on top over and break up 4 into 2 times 2. And then you'd be getting rid of those common factors to get an answer of 3 over 2. So that's the concept that we're using right now. So if you understood multiplication, division is going to be the same thing as what I just did in that last example, but I'm going to have to remember to flip that second fraction. Okay, so we're going to look at 2 more examples for some division problems, and that's going to be it for this section. So divide rational expressions. So I've got x squared plus 5x plus 4 divided by x squared plus x minus 12. So that is my one rational expression. I'm dividing it by the next rational expression. So x squared minus 1 over 2x squared minus 6x. All right, so a couple different ways you can start this. You can start and flip it over right away. You can start factoring everything and then flipping. Pros and cons to both. So I'm going to, some students will flip right away and then factor so they don't have to write it all out a second time. I'm going to factor it first and tell you why when we get down to the end, why I factored it first, and then it'll be up to you if you want to continue that way. But I'm going to go ahead and factor the top here. So what multiplies to 4 but adds to 5? So 4 and 1. I'm going to factor this denominator. What would multiply to negative 12 but add to 1? So that'd be 3 and 4. My 4 needs to be positive. My 3 would need to be negative. I'm going to factor my x squared minus 1. So that's x plus 1 times x minus 1. I'm going to factor my 2x squared minus 6x. So that has 2 terms. It doesn't have the 3. This doesn't have that c term, so it doesn't have that number. So this is where I pull out that greatest common factor, 2, and it also has an x. So then what's remaining would be x minus 3. So make sure you're still checking for those greatest common factors. Now I can't cross anything out yet because this isn't a multiplication problem. I still need to flip this next fraction. All right, so I've got x plus 4 times x plus 1 over x plus 4 times x plus 3. Now I'll change it to multiplication, and I'll put the 2x times x minus 3 on top, and the x plus 1 times x minus 1 on the bottom. So some students would flip right away so that they didn't have to factor, write this out, flip it, factor, and multiply. Up to you. I'll talk about why I did that, and then as long as you can keep track of it, it'll be your choice. So now that it's written in a multiplied form, really, it's all on the top and all on the bottom. So anything in common in the top and bottom as factors could divide out. So my x plus 1s, my x plus 4s. That is it. So I have on top 2x times x minus 3. On the bottom, I have x plus 3 and x minus 1. All right, so what you need to make sure you pay attention to with division, other than that you have to flip it, when we do our restrictions, you need to be careful to include all of your restrictions. All right, I will have students that will forget some because, well, first let's look at this denominator. So here, what value of x would make that 0 would be negative 4. So we can't have 0 in my denominator, so that cannot be a value for x. Right here, what value of x would make that 0? That would be negative 3. Can't have that. Right here, x plus 1, what value of x would make that 0? Well, that would be negative 1. We can't have that. Here, what value of x would make that 0? Well, that would be positive 1. All right, so that's typically students will get those correct, but the part that they will miss is that we had this as part of our denominator at one time. All right, so if there's ever a variable in your denominator, we have to restrict on what it can be because the number doesn't exist if it's ever going to equal 0 in the bottom. All right, so I'll have students that will miss that, and so that's one reason why I did factor first. So you'll have to check all of your denominators, but technically the numerator and denominator for what you're dividing by, because at one point it is a denominator. Okay, so right here, this 2x, what value would make that 0? Well, that would be 0. And then x minus 3, that would be 3. So we have a lot of restrictions. All right, every problem is going to vary. It's going to be how many different factors do you have in your denominators is what's going to make how many restrictions you would have. Okay, that's division. I want to look at one more problem for division. And this will be our last example for this lesson. So 3x to the third divided by 5y squared. Elementary division symbol. And then 6y to the negative third divided by 5x to the negative fifth. All right, so I will have students that will be thrown off by this one because all the last examples, what have we been doing? We've been factoring. You don't need to factor something like this. It's already written in a multiplied form, right? 3 times x to the third, 5 times y to the second. They're already multiplying. It's when I have 3 plus x to the third. Now, well, I wouldn't be able to factor that anyways, but now that's something that you're looking at to factor. Okay. Something else that throws students off with this one are the negative exponents. You can take care of the negative exponents first, or you can wait. All right, if you decide to wait and just take care of them, write this as a multiplication problem, I will warn you, when you change that to multiplication and I flip this, I am not changing those exponents to become positive when I flip it. I'm flipping it because I'm changing it to multiplication. All right, I cannot do both at the same time. Okay, for one thing, the 5 and the 6 are not being raised to a negative exponent, so they wouldn't have flipped anyways. Okay, you can change them now. My suggestion at this point would actually be to now multiply across the top and bottom. I know I said don't do that on some of the other problems, but when I'm in a situation like this, or I want to go back to my multiplication problem. When I'm in a situation where I'm multiplying giant polynomials together, I don't want to do that. I just want to factor it. That's going to make it easier. Now I'm in a situation where I'm multiplying 3x to the third times 5x to the negative fifth. I can get a simple one answer for that, right? 3 times 5 would give me 15. These have the same base, so I can go ahead and add their exponent. So that would be x to the negative second. My denominator, I'm taking 5 times 6, so that would be 30. And then y squared times y to the negative third would be y to the negative first. Okay, now if I were you, I would change that to go to the bottom to become a positive exponent, and y to the negative first needs to go to the top to become a positive exponent. So I will have a y on top, and I will have x squared in the bottom. Okay, I still have common factors. With 15 and 30, I can divide each by 15. So I have a 1y on top over 2x squared on the bottom. And that is my simplified answer. So no factoring in a situation like this. All right, you'll still have restrictions, but notice you have 2 variables here. So make sure you pay attention to that because you're going to have restrictions on x and restrictions on what y cannot equal. This isn't too difficult to figure out the restrictions. So I have 5 times y squared, well, I can't multiply it by 0, it'll make it all 0. So y can't be 0, and then same thing with x cannot be 0. Okay, that is it for our lesson today. Good luck with your homework.